So welcome back. In this video we will write a program to test if a given number n is a prime or not. So if you are wondering what is a prime number, n is a prime number if its divisors are only 1 and n. So how are we going to solve this problem? We are going to search for a divisor for n, and if we can find at least one divisor other than 1 and n, so this n will not be a prime number. This is how we are going to solve this question. So in exercise 4 we found the divisors of a number n. So I copied this code and I put it over here. I'm going to make small changes. So first of all, we are interested in all the numbers greater than 1 and less than n. We want to see if any one of these numbers is a divisor of n. So this loop will start from 2. And as we said before, all the divisors of a certain number n are less than or equal to n over 2. Of course, other than the number itself. Okay, so now this loop iterates over all the numbers from 2 up until n over 2. So if we find at least one of these numbers to be a divisor of n, then we say that n is not a prime number. So what I'm going to do here is I'm going to print not prime. Okay, but what if n is a prime number? So this message will not be printed because this condition will never be true, and we have to print that is prime. Okay, but this line of code will be executed if n is prime or not, because as you can see there is no condition to execute this line of code. So in order to fix this problem, I'm going to make a new variable of type boolean. I will call this variable is prime and I will initialize it to be true. So I am supposing that the given number is prime, and if I find a divisor for this number, all I have to do is to set is prime to be false. And now outside of the loop I'm going to say if is prime, I will print is prime, and if not, I will just print not prime. Perfect. So this solution works. So what's happening exactly? First of all, is prime is set to be true. Then we are searching for a divisor. If we find a divisor other than 1 and n, is prime will be false. So if is prime remained true, this means that we didn't find a divisor. This condition will be true, so this statement will be executed. And if this statement was executed, this means that we found a divisor. This condition will be false, so this statement will be executed. So this is a solution for this problem, but we can make it a little bit better. So for example, let's say n is 15. 3 is a divisor for 15 and 5 is a divisor for 15. When this loop reaches 3, is prime will be set to false. And this is enough for us to say that 15 is not a prime number. But this loop will continue and will search for other divisors. So what we are going to do right now is the following. I'm going to add a block of code here, and inside this if statement I will set is prime to be false, and then I will break out of the loop. Now back to our previous example, whenever I is equal to 3, is prime will be set to false and we are getting out of the loop. So we are not searching for other divisors, and this is the perfect solution. So let's run the program. So enter a number, we will try our 15 and it prints out not prime. I will run the program again and I will try with a prime number, let's say 7, and as you can see we get is prime. So if you understand everything, you can now stop the video. For those who are still a little bit confused, I'm going to explain exactly what's happening here. First of all, we have 15 and I is firstly equal to 2. So is 15 divisible by 2? This condition is false. So we're going to increment I. Now I is equal to 3. So is 15 divisible by 3? This condition is true. So is prime will be false. Then we are getting out of the loop. Perfect. Now if is prime, This is false, so this statement will not be executed, and this one will be executed. That's why we see not prime. Perfect. Now for our second example, we have 7. So I is first of all equal to 2. So is 7 divisible by 2? The answer is false. So we will go and increment I. Now I is equal to 3. Is 7 divisible by 3? The answer is also no. So we will increment I. And now I equals 4. So this condition is no longer satisfied because 4 is greater than 7 over 2, which is 3.5. So we are getting out of the loop with is prime equal to true. So this is true and this statement will be executed. That's why we see is prime. So this is it for this video, and I'll see you in the next one.